For this final part, we're asked to find an estimate for the gradient of the curve where x equals 3.5. Now, there's two ways to find the gradient of a curve, broadly speaking, that you've learned. To find the gradient, you can either differentiate, but this one says find an estimate. Differentiation gives us an exact value. So if we're estimating, and in fact we haven't got the equation of this curve, all we're told is that it's y equals g of x. To find an estimate, we have to draw a tangent and then find the gradient of that. So on my graph I've drawn this tangent at x equals 3.5. I've tried to be as exact as possible. I've used my ruler to try and make sure that the angle here and the angle here look about the same, and which they do. So to find the gradient, I've picked 2 points in the curve. I've got this one down here, which is at 1.5 minus 9, and this one here, which is at 4 and 13. As always, to calculate the gradient, I want the rise divided by the run, or the change, the delta y over the delta x. My delta y here, it goes from 13 to negative 9, so I make that 22. And the delta x, it goes from 1.5 to 4, so I make that 2.5. So to get my final answer, I've got the gradient is approximately 22 divided by 2.5, which is 8.8. In fact, the answer given, they'll accept any answer from 6.5 to 11 inclusive, as long as you've shown all your working. Now, in terms of showing all your working for this one, it's important to have shown the line you've drawn, and then to show the working, I mean, if you've shown what I've done on the graph, that's fine. If you haven't quite shown all of this working actually on the graph, which I would recommend, it might be worth showing how you've got that 22 and that 2.5. So the 22 I get from 13 minus 9, that's up here, and the 2.5, the delta x, is 4 minus 1.5, which is here.